Hello. I was asked yesterday if I would show an example of the last part with this assignment, with the last part of each problem, with how to do this table. So that's what I'm going to do. There are YouTube links or video links in the description of the assignment on reminders of how to do the system schema and how to do the energy bar charts. Excuse me, and how to do this energy equation. So the only thing I'm going to focus on is making sure we have this part here. So I will take a look. The data section is really just where we go and we put the information that is given to us in the problem. So I'm going to do a little bit of back and forth scrolling here. So I scroll up to the question, and a doll sheep is kind of a mountain goat. One eats zero point 0.5 cups of blueberries, has a mass, the sheep has a mass of 150 kilograms, excuse me, and it climbs 110 meters on Earth. So we see there's the 110 meters. You may or may not have seen there's the where the doll sheep starts, there's where the doll sheep ends. The climb was 110 meters. So when I go down here, I can say like the height equals 110 meters. Then I can go back up here, and the sheep has a mass of 150 kilograms. So I can say down here that the mass of the sheep is 150 kilograms. And that's a big one, right? So 150 kilograms is a little over 300 pounds. So they're not tiny. What else do we know? So those are the two pieces of information that are given to us here about the sheep climbing. They also tell us that it eats zero point 0.5 cups of blueberries. I don't know if that will be helpful. I'm going to put volume blueberries equals zero point 0.5 cups. It's conceivable that in some cases we might be given data that we don't know how to use. And, hey, if we don't know how to use it, it's probably worth writing down so we at least have it available to refer to. And then there's one more thing that we know that is data here that they don't flat out tell us the number. Um, so the one thing that we know that we've reviewed and used, but they don't tell us, is that well, the sheep is on Earth, and if we're on Earth, we know G. That value for G is 9.8 newtons per kilogram. That's not a force. It tells us information about the field of the gravitational field of the Earth. It's not a force, it's the field. It's a slightly different thing. So that's all of the information that we know. The other piece of data that might be useful to put in to include here is that we don't know what the gravitational energy is. So I'm going to put E gravitational equals question mark. So that's the plan there. To make it maybe look party, I'm going to just make that a subscript. And if you're wondering, I highlight it and then oops, uh, when I highlight it and then just do, once it's highlighted, I hit Control, comma, that makes it lower like this. Okay, so that's how I do the data section. The equation plan, no numbers. This is just trying to make sure that we don't think of this purely as a number of things flipping back and forth. The equation plan, I'm going to say E gravitation equals, and then this again, this is where we write out or include the equation that will be useful for what we're doing here. And you might remember from our slides earlier, the gravitational energy or the gravitational potential energy is the mass of the object times G times H. So that's the plan. I'm going to use this equation to calculate the gravitational energy. When I go over here, I have G, I have M, I have H. Really, this is H final. I'm assuming H initial is 0. So then over here, I just go through and I plug that stuff in. I'm going to do one thing to kind of show you how to adjust things if you need to. So on this one, as I type, oops, gravitation, as I type, it's going to end up kind of wrapping around and it's going to show me as running out of space. So I'll show you how to adjust that in just a second here. So I say E gravitation is, well, my equation is plan for M is 150 kilograms. So here I'm going to put 150 kg. And then times G, which is 9.8 newtons per kg, and then times H, which is 110 meters, 110 meters. So here I kind of ran out of space, right? It started wrapping around, and if that really is bothersome to you, you can go up here, and if I grab the bottom one, that slides both the bottom and top. I'm clicking and holding and dragging things over. If I bring it all the way over there, it gets me to the edge. Um, if it's something that really bothers you, you could just put EG in there, and then that gets closer. Yeah. If it really, really bothers you, oops, we could highlight this. It still needs to be readable. It's conceivable that we might be able to make this a smidge bit smaller. That's really tiny, but that gets everything on one line if we really are curious or want that. Um, so that gets all of that stuff in there. And then answer with units of measure, e.g. equals. And then if I multiply all of this out, I get what I get. I'll pull up the calculator here. I don't know, I have a calculator on my screen. I don't know if this set as it is, if you can see the calculator or not. So I do 150 times 9.8 times 110, and I get 161,700. 161, comma, 700. And then I'm going to just down below here show you how some of the units kind of work. If I do a kilogram is the same as a kilogram over 1 times a Newton per kilogram. If I do a kilogram over 1 times a Newton per kilogram, the kilograms cancel out and I end up with just newtons. So I can say it's that many newtons, and then I take it times a meter. So it's that many Newton meters. Or we could just say it's that many joules, same thing. J for joules, spelled differently than like if you are looking at a ruby or different stones that we consider to be joules. This is JO joules, named after a person that did some work with energy. There you go. That's what's expected for completing these sort of blanks. You don't necessarily need to show all of these steps on this far right. You can put the answer just one or the other. That's perfectly fine. If while you're typing this row, if you don't care about the things kind of wrapping around line to line, well, that's fine by me. So there you go. Have a good one, folks.